Hello, ladies and gentlemen. Welcome to Math 30-2, Chapter 2, Section 3, Permutations when all objects are distinguishable or different, Part 3. Now, we just did the online banking passwords. 62 choices. When you have 5, 6, or 7 letters, you get a total of like 2.5 times 10 to the 12. Different choices. Now, suppose an online magazine requires each subscriber to have a password with exactly 8 characters using the same requirements for characters described in the previous problem. Which is more secure, the bank website or the magazine? Well, magazine. 62 letters. Choosing 8. I just did it up here. 62 and here 8. 1.36 times 10 to the 14. 1.26, 14, 21 right there. Don't care. Now, check my work. Because that's greater than the bank. The total for the bank is the number above it, 2.52 times 10 to the 12, 2.52 e to the 12. Alright? So, your online magazine subscription is more secure than your bank. No comment. Okay. That's what I need you to be able to do. Okay? Now, not moving on, but let's show some variations. Permutations here. Now, I want to review chapter 1, or section 1 and 2. Anyway, let's do some questions. At the Revolution Ford dealership, 9 different trucks are lined up for ease of view. The 3 red trucks must be parked so that there is a red truck at each end, and the 3rd red truck is exactly in the middle. How many ways can the 9 trucks be parked? Well, 1, 2, 3, 4, 7, 8, 9. So how many red trucks do we have? 3. Okay? There's 1 red truck at each end, and the 3rd red truck is exactly in the middle. So the first one here has to be red truck. How many choices for red trucks do we have? 3. We use 1. Then we go to the other end. How many red trucks do we have left? 2. So how many choices do I have for this one? 2. And then we go to the middle. We have 1 red truck left. So, exactly in the middle. Apologies. And what about the other trucks? Well, how many other trucks do we have? We had 9, we used 3, down to 6. This is 6. 6. 4. Oh. So this is 6 factorial. This is 3 factorial. Okay. How many ways can they be lined up? Now, grab your calculator. What is 6 factorial and 3 factorial? 6. Four, 3, 2, 0. Alright. So this is factoring notation, and I want to point out, not always do we need the permutation formula. Sometimes it's just factorial. You really do have to read the question. That's why I'm going over this. Now, let me show you. Sorry. I'm going to stop for a moment and make certain you got this. The restrictions, 1 truck at each end, and the 3rd road truck is exactly in the middle. Now, different question. At the Revolution Ford, 9 trucks. 9 different trucks are lined up for ease of view. 9 different. Okay? So the 3 red trucks must be parked side by side. How many ways can the 9 trucks be parked? Now, do you see the difference here? Must be parked side by side. So somewhere in there, we have a clump of 3 trucks. Right? Side by side, it's a clump of 3. Now, how many choices do I have for the first one? 3. How many choices do I have for the second one? 2 and 1. So there's a 3 factorial. Now, how many ways can it be parked? Well, this is one big truck. So it's 1, 2, 3, 4, 5, 6, 7. Notice a very slight difference in wording. A completely different question. And yes, I can go back and change the number. If I'm lazy. 30,207. I'm too fast. I apologize. I'm going to pause here. I want you guys to look at this, check my math, and then we're going to go on. Okay? So pause the recording. All right, welcome back. See the difference? Here, the 3 trucks are one big truck, one clump. Or one big truck. Okay? One big truck in there. Confusing. Anyway, so, I want to point out a hint. When repetition is allowed and r is less than n, we can just use n to the r factorial. Let me give you an example. The number of 4-character passwords using only the 26 lowercase letters, where letters can be repeated, is 26 times 26 times 26 times 26, so 26 to the 4. All right? Notice, if it wasn't repeating, so this is 26 and 26. When repetition is allowed, if repetition is not allowed, we said not repeat, then this is 26 T4, which is a different number. If there's no repetition, we have to use permutation. 26 and yeah. That's annoying, and that's what I want to stress here. The math doesn't happen. Gosh, darn. Gosh. It can be confusing if you have to pay attention. And what is 26 for? Notice with repeats, there's a lot more options. Anyway, here's what happens. Fewer restrictions, more numbers offered, bigger numbers. Now, moving on. A social insurance number, SIN, in Canada consists of a 9-digit number that uses the digits 0 to 9. How many SINs can be created if each digit can be repeated? Well, 0 to 9, how many choices do we have for the first digit? 10. How many do we have, how many options do we have for the second? 10. They can be repeated as 10. 9. I'm running hard on that one. 9 power. Of course. 1 billion. 1 billion. Right? So far, so good? Well, one more question for this video, and then we go on to the last part. How does this compare with the number of social insurance numbers that can be created if no repetition is allowed? No repetition. How many choices do we have for the first? 10, we've used one, 9, 8, 7, 6, 5, 4, 2. Now we can multiply that out, or I can find out that's 10 We're choosing 9 of them. Yes. So we do permutations in here. And 10 choosing 9 is 862, 628,800. Which is a lot less than a billion. I'm supposed to stop at 10 minutes, but we've got 2 more quick questions, so let's get them done. Alright, so the Canadian government does not use 0, 8, or 9 as the first digit, and repetition of digits is allowed. How many are there? So is allowed. Repetition is allowed. How many sins? How many are there of these? How many sins? I would say, how many sin numbers are there? Anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we do not use 0, 8, or 9 as the first digit. So how many digits are left? 1, 2, 3, 4, 5, 6, 7. So just the first digit. How many choices do we have for the next digit? Repetition 1, so we've got 10. 10, 10, 10. So we've got this calculated about 700 main numbers. A population of 30-something million right now. That's plenty. Okay. Last question. Sins starting with the digit 9 are issued to temporary residents. How many sins are there in total? So can we do this a permutation? I don't think so, because I didn't say so, but did I say anything about repetitions? No, so we can assume that digits are repeated. So a restriction, digit 9. That's one choice for the first digit. What's left? Well, every other digit we repeated. So it's not 10p8, it's 10 times 10 times 10 times 10 times 10. So we can give 100 million social insurance numbers to temporary residents. Alright? So that's it. Now, more permutations. Chapter 2, Section 3. If any questions, shoot me an email or watch the video again. Otherwise, I'll see you in class. Good luck.